page 3 of the Algebra 1 pre-course test. This is information that will be taught to you throughout the school year, as well as information that you should know. So this is building that foundational base in order to be prepared as we move towards the beginning of the school year, which is in a couple weeks. So we're going to do 8 problems in page 3. The first one is definitely new. It is something that is not relatively known, and it's correlations. So it says identify and interpret the correlation coefficient in the linear regression results. So you have a line, because it's y equals mx plus b. M, the slope, is 40.5938. The y-intercept is 15. And then statistics. This is the R value, which is a correlation coefficient. So we have R, and then we have R squared. So that correlation, it wants to know to interpret the correlation. So since R is 0.988, and we see a numerical value between -1 and 1 that quantifies the strength and direction of the linear relationship. So when the absolute value of R is approximately 1, there's a strong correlation. When it's closer to 0, it's a weak or no correlation. When it's positive, when it's negative, yes, we know that. So this has a positive, strong correlation because it's very close to 1. So we would say positive because it's greater than 0, and strong correlation. So that's how you need both of those criteria. Not only whether it's strong or weak, but whether it's positive or negative. And then we can look at that R squared value. It doesn't ask about the R squared, but this value is the square of the correlation coefficient. And of course, squaring it's going to make it positive. And R squared represents the proportion of the variation in the dependent variable that can be explained by the independent variable. For example, if R squared is 0.75, it means 75% of the changes in the dependent variable, y depends on x, can be explained by the independent variable in the model. So the higher R squared generally indicates a better fit, because that would be 90% is affected by the change. So in this case, it's 98% causation. Number 20, write a piecewise function represented by the graph. So as we input our x's, what are our outputs going to be? And so the formula for y equals, so when x is less than 0, because it can't be less than or equal to, what's that graph right here? Well, that is a slope of -1. Sorry, it has a slope of +1. And it has a y-intercept of -1. So as x is less than 0, we're going to use this formula. And it actually is written like this, sorry. It's not the best. And then when x is greater than or equal to 0, we have a -1/2. No, -2. Sorry, -2, because it goes down to right 1. -2x, and then it starts at -2. So as x is less than 0, we use this formula. And we're going to erase that 1 because we don't need the coefficient 1. It's understood there's a 1. X minus 1, and when x is greater than or equal to 0, we're going to use this graph. So if we plug in 0, we would expect to get 2. So plug in, or -2. Plug in 0, you get -2. When we plug in 1, we would expect to get -4. Plug in 1, you get -4. If you plug in -1, you would expect to get -2. So if we plug in -1, you get -2 because it's to the left of there. I like piecewise. Write the equation for the nth term of the arithmetic. So very important to notice it's arithmetic sequence. So, and then find a of 20. So the first thing we have to do is find the common difference. Common difference. And what is it changing? It's plus 10, plus 10, plus 10. So my common difference is 10. My a sub 1 value is 53. That's the first term in the sequence. And so with that, we can say a sub n equals, and this is the formula, a sub 1 plus n minus 1 times d. So filling in a sub 1 and d, we get 53 plus n minus 1 times 10. And that would be, and then we can simplify this. So we get a sub n equals 53, distribute, plus 10n minus 10. So a sub n equals 10n plus 43. That is the formula. So both of these formulas are correct. This is simplified. This, you can see the information. This, you can't really see it. This is in slope-intercept form. So this one, I like this one because you can see what your a sub 1 value, you can see what your common difference is. And then we have to find a sub 20, I think it was. A sub 20, the 20th term in the sequence. So we plug in 20 for n, which represents the number in the sequence. So a sub 20 equals 200 plus 43. So the 20th term in the sequence is 243. So if we continued this going, the first term, second term, third term, fourth term, if we got the 20th term, it would be 243. Also love arithmetic sequences. All right, 22. You buy 4 small candles and 1 large candle for $18. So 4 small plus 1 large equals $18. Your friend buys 5 small candles and 2 large candles, and that costs them $27. What is the cost of each small candle, of each large candle? So we're going to use a systems of equation. We can either isolate and do substitution, or we can do canceling. I'm going to do canceling, and I'm going to multiply everything by -2. So that creates the equation -8s minus 2l equals -36. You have to multiply everything by -2 to create a proportional equation. And this one I'm just going to bring across. I don't have to multiply or manipulate it. That's 5s plus 2l equals 27. And now I'm going to add them. I'm going to add their columns. So -8 and +5 leads -3. These cancel. That was my elimination. That eliminates the L variable. And it leaves me with -9. Divide by -3, divide by -3, S equals 3. And that is going to be the cost for a small candle. And now I can go back to this equation. Let's take this, 4S plus L equals 18. Let's substitute 3 for S to find out what L equals. 12 plus L equals 18. Minus 12 minus 12, you get L equals 6. And so the large candle costs $6, the small candle equals 3. So small candle, that's not how you spell candle. Small candle is $3, large candle is $6. Good. Yep. Determine the number of solutions in the system. So remember when we substitute and the variables cancel, and here's the first situation. If you get a true statement, that means there are an infinite many. Not infinited, infinite many. And if it's false, if the variables cancel and you're left with a false number statement, there is no solution or zero solutions. And then if the variables don't cancel, you'll get one solution in a linear equation when you have two linear equations. If you have a linear and a quadratic, you're going to have 0, 1, 2. So here we have 1. These are linear, so we're going to substitute this in for y into the other equation. So 2x plus 2, instead of writing y, we're going to do negative x minus 4 equals negative 8. So we're using this equation, 2x plus 2 times my y equivalency equals negative 8. So 2x minus 8 equals negative 8. These cancel, you're left with, so the variables cancel, and you're left with a true statement. So there are going to be an infinite many number of solutions. And the reason being is they're the same line. Okay? When they're the same line, they lie on top of each other, and there would be an infinite number of intersecting points. Solve this by graphing. This is an interesting one. I like this. This is kind of cool. I learned this in this book, in Big Ideas. I'd never seen this before. So first thing we're going to do is we're going to graph this line with a 4, 1, 2, 3, 4 y-intercept, slope of 2, up 2, right 1, or down 2, left 1, down 2, left 1, down 2, left 1, and we can make a line. So these are all the solutions to that equation. And then we're going to graph this coordinate, negative 1, and a slope of down 1, left 2. No, sorry, down 1, up 2. Can't do double negative, it's just one negative. And I'm going to put it to the numerator, so down 1 from the y-intercept, and then right 2, positive. Down 1, right 2, or up 1, left 2, up 1, left 2. And if we graph that, we notice that we have one point of intersection. That point of intersection is going to be negative 2, 0, would be the solution by graphing. It's kind of cool because that's a way I've never really seen. You could have solved it and then plugged in the value, but this is way easier, that we can just graph each of those sides as if they were linear. I always think that that's kind of cool. That is the point of intersection. So actually it is not, it doesn't have a y value. Look like it should actually. Sorry. If we solve it, x equals negative 2. Sorry. It's not a point. It's actually going to be the line. It's going to actually be this. So the solution is actually x equals negative 2. That would be the solution. So it's because there's only an x value, we can only have x outputs. So where x is negative 2. Sorry about that. A little confusing. All right, this is an inequality. So things we need to remember about inequalities is when you have less than or greater than, you're going to have a dotted line and open circle for the points. And if you have less than or equal to or greater than or equal to, you're going to have a solid line and closed points. Since this is just less than, we're going to go to negative 3, open circle. We're going to use the slope, 1, 2, 3, right 1, open circle, and now we're going to do a dotted line. Not purple, but that's okay. Let's do this. Let's put arrows on them. Let's make that black. And that should be, there we go. So graph it. And now, because it's an inequality, this is just the border. This is the border, and now we have to see less than. Well, the best way to do this is to test a point. So we're going to test a point. Since it doesn't go through the origin, we're going to use the easiest point, 0, 0. We're going to plug it into this equation. Plug in 0 for y, 0 for x. We get 0 is less than 0 minus 3. Is 0 less than negative 3? Is 0 less than negative 3? No, that's false. 0 is greater than negative 3. That's false. So this point is false, and that means every point on this side of the border is going to be false. This side is going to be true, and so we want to always shade the true side because those are the solutions. So we would graph on this side because this point is false. All these points are false. If this side is the false side, that means this side must be the true side. Good? And all the points on the boundary are false because they're open circle. Number 26. 26 says you have at most 8 hours to spend at a beach and a museum. You want to spend more than 2 hours at the beach and at least 2 hours at the museum. Let x be the number of hours at the beach, y be the number of hours at the museum. Write a system and represent the situation. You have at most 8 hours to spend at the beach and museum. Well, beach is x, y is museum, so x plus y at most 8 hours. So this needs to be less than or equal to 8. It can be equal to 8, but it can't be greater than that. Now you want to spend more than 2 hours at the beach and at least 2 hours at the museum. So I want to spend more than 2 hours at the beach and at least 2 hours at the museum. How am I going to write that? Yeah, right. All right. So beach is x, more than 2 hours, and I want to spend at least 2 hours at the museum. So y has to be greater than or equal to 2. You want to spend more than 2 hours at the beach, not equal, more than 2 hours, and at least the lowest that can be is 2 hours. So it has to be greater than or equal to 2. Let x be the number. Write a system that represents the situation. All right, that's the system. That's how we would write it. Yeah. Okay. So, and then you can graph each of those and see where they intersect. Using Desmos is kind of cool. We could plot these all into Desmos. Let's give it a little shot here. Let's do Desmos. Whoa. Why didn't that work? Desmos. Let's graph. Let's put each of those equations in there. Let's do x plus y is, what did we say? Less than or equal to 8. Boom, that's that. X is greater than 2. That's a third graph. And then y is greater than or equal to 2. So where do all three of them, where are they solutions? So it's going to be in between this. That's where it's triple shaded. Pretty cool, right? So this is the green. This is y is greater than or equal to 2. This is x is greater than 2. And then this line is x plus y is less than or equal to 8 is this one. So that's how it would look. Any of those points inside here, if we took a point in here. So let's focus in. If we took the point 3, 3, would that be true for all three of them? 3, 3. 3 plus 3 is 6. Is 6 less than or equal to 8? Yes. Is 3 for the x value greater than 2? Yes. And then 3 on the y value, is that greater than or equal to 2? Yes. Let's look at a point that is outside of it. Let's look at the point 1, 1. Is it true for all three of them? So is 1 plus 1 less than or equal to 8? Yes, hence why it's shaded red. Is 1 greater than 2? No, hence why it's not in the blue. And it's also not in the green shaded area, for 1 is not greater than or equal to 2. So that's a neat way of seeing how each of these affect each other. Good. So that's a little added one on what the solutions are. Good luck with page 3.